Hello and welcome to a video on parallelograms. So we're going to look at properties of parallelograms, and there's four properties plus the definition. And what a parallelogram is two pairs of opposite sides that are congruent, and we're going to count that as one of our properties in a minute. But first I want to point out that the blue lines here, the blue shapes, those are the parallelograms, and the gray segments inside of them, those are the diagonals of the parallelograms. And the diagonals, if you look at the ones on the left, the diagonals create two congruent triangles. And that's really important to remember when you're looking to find different sides or angles. So just a very quick explanation of that is, since the sides are parallel, we can say these alternate interior angles are congruent here and here. We can say that, let's see, these alternate interior angles are congruent here and here based on the top and bottom, and we can say that the same side is congruent. And so from that, the triangles are congruent. And so what we're going to see from this, because the triangles are congruent, it follows that corresponding parts of the triangle are congruent, and so it makes sense that these opposite angles are congruent, and that's one of our properties. Opposite sides are congruent because they're corresponding parts as well. And then these opposite sides are also congruent because they're corresponding parts as well. So when we're looking at two congruent triangles, we've got all the parts, and it just so happens that those parts make up two of the properties right there. So opposite sides are congruent, opposite angles are congruent. And the same is true, it doesn't matter if the triangle is slanted a different way or if the diagonal goes the other way, you're going to still get the same thing. You're going to get alternate interior angles here and here, therefore, and also the same side, and therefore corresponding parts are also congruent here, here, and here. We need three of them there, don't we? Okay, now that's two of the properties. So we've got the definition and two properties. Now the next thing has to do with the smaller triangles. So when you form two diagonals like you're looking at on this remaining triangle here, the top and the bottom triangles are congruent, as are the left and the right triangles. So because here we're looking at alternate interior angles, right? And here we're looking at vertical angles, right? And because of what we see over here, right here and here, we can conclude from that these are also congruent. These sides are congruent. So we know that we've got the top and bottom triangles are congruent by angle, angle, side. And therefore what follows from that is that these angles are also congruent because they're corresponding parts of congruent triangles, that these sides are congruent, so we'll just give them 1 mark, and that these sides are also congruent, so we'll give them 3 marks. All right, now what this one implies, because of those diagonals, the way that they cut each other right in half, the diagonals bisect each other. Right? That's the next property. And then the last property here, let me just draw one more pair. Okay, and the last property is really an old property. There's really nothing new here. It's just we're applying it to parallelograms, so we're going to call it something different. And here's the property. Since opposite sides are parallel, this is parallel to this, and this is a transversal. And so these two angles here and here, which are different, are same side interior angles. And remember, same side interior angles are supplementary. Okay, well here we're not going to call them same side interior angles, we're going to call them consecutive angles because they're the ones that are right next to each other. So we know that the angles that are across from each other, like these two here and here, any angles that are across from each other are going to be congruent. Any angles that are right next to each other, one after another, like here and here, are going to be supplementary. So there's our last property. All right, so let's come over here and let's name our properties. So we've got 5 things. I'm going to use a little bit of abbreviation. Parallel, I'm going to use this abbreviation for parallel, and congruent and opposite. I'm going to just use OPP for opposite. Okay, so the first thing is, what is a parallelogram? That's just the definition. I'm actually going to just kind of call this the definition so we know. It's a property, but it's also the definition, and that is that both pairs of opposite sides are parallel. So two pairs of opposite sides are parallel. There's the abbreviation. All right. Number 2, both pairs of opposite angles are congruent. Okay. Number 3, both pairs of opposite sides are congruent. Number 4, diagonals bisect each other. And then the last one is that consecutive angles are supplementary. Okay, that is a lot of information. We know a lot about parallelograms. So let's get to work and let's look at the first problem. We're just going to use this information to answer questions about sides and angles when given what we're given. All right, so I'm going to actually fill this out before I do anything else. Let's do number 1 together. So I'm going to fill out, I know that opposite sides are congruent, so these have to both be 15. These have to both be 8. I know that opposite angles are congruent, so these have to both be 68. And I know that consecutive angles are supplementary, so 180 minus 68 gives me 112, and these have to both be 112. All right, I'm looking at a parallelogram, no diagonals. It's a simple situation compared to like number 3 where we have those diagonals in there. And now we're just going to fill in the information that we've just written down. So AD, the length of AD is 8. The length of DC is 15. The measure of angle A is 112 degrees. The measure of angle B is 68 degrees. And the measure of angle C is also 112 degrees. All right, let's try one that has those diagonals in there, and let's see what we come up with this time. All right, so let's see what we can label here. Now notice that there's no angles mentioned. Sometimes the problem has angles and side lengths. Sometimes it just has one or the other. All right, so this time we're told, well, here's one right down here, RT is 30. So that tells me the whole distance from R to T is 30. And remember that diagonals bisect each other, which means these two pieces have to be the same. So they're equal parts of 30. They're each going to be 15. All right, what else do we know? Well, the same thing is true here. These two have to be equal as well. So we're given one of them is 7. The other one has to be 7 too. And then we're just back to the other stuff that we just did. Opposite sides are congruent, so these are both 18. These are both 27. So we can just fill in what's over here. So UT is 27, ST is 18, VS is 7, and VT is 15. Okay, there we go. Now here's a parallelogram that instead of having all of the side lengths, it has all the angle measures. So it can be a little bit trickier with angle measures. You have to remember a lot of things like the consecutive angles of the whole parallelogram are supplementary, like the angles of a triangle add up to 180, and sometimes, there's a lot of stuff that you have to bring back into your memory for these. So let's see what we have here. So we have angle 21. So we have to remember it. It's really helpful to remember alternate interior angles and see those kinds of angles. It's also good to remember the congruent triangles that we saw right over here when we saw something like this, and we recognize which triangles are congruent, like this triangle is congruent to this triangle over here, and exactly which parts of those are congruent and how there's sort of a twisted hourglass. So these are the ones that are the same, not the ones that are like both on top or something. So that's helpful if you can think that, keep that in mind while you're working on these. All right, so let's see what we have here. So we have that situation. We have some parallel lines, and I'll just draw the parallel lines and I'll just erase them, whatever we need to answer a question. So here's a pair of parallel lines right here, and here's a transversal, and there's your Z. So these angles have to both be equal. So they're both 71. Okay, I'm going to erase that and just put the 71 up here. I think that's a little, let's try this one. Okay. Same thing is happening with a Z going this way. You see it? So those angles are both 21. So let me erase that and put the 21 here. All right. Now, what else can we do? We can look at the consecutive angles. Well, we don't have enough for consecutive angles, but we need to observe this down here. So angle FED is 134. So let's see if we can find that. So FED is this angle in here, and that whole thing is 134. And so if that's 134, these two have to add up to 180. So this is a little bit tricky, like I said, but we know that this 21 plus this angle, then I'm just going to call it x for a minute, so plus x plus 134 equals 180. That's one way of thinking about it, okay? Another way of thinking about it is maybe there's some other things we could have done first instead that would have been simpler to see. So maybe another thing would be, instead of going that route, to say if this whole angle here is 134, FED, and we already have 71, maybe we just find this angle right here. That might be easier. So why don't we find that? So 134 minus 71. Honestly, I didn't even see it until I started to work out the other one. I thought there's got to be something easier than that. And we found something. So this is 63. Well, that gives us another pair of alternate interior angles. Here's another Z. So there's another 63. Okay, now you may notice that there's a new triangle that was just formed here, that a new triangle that we have two of the three angles, which means now we can jump from thinking about parallelograms to just thinking about triangles. These two angles inside this triangle add up to 63 and 21 is 84. So 180 minus 84 gives us 96. So that means this angle in here is 96. And vertical angles, this is 96. And supplementary or a linear pair here makes 96 minus 180. This must be 84. Oops, I don't know why I put that one there. 84 and 84. And now we can use the three angles of a triangle to get the third angles over here. So let's see, this is 84 and 71. I'm looking at this triangle over here now. So I've got 84 and 71. Adds up to 155. 180 minus 155 gives me 25. So I just found this angle in here is 25. Another pair of alternate interior angles must be formed. So let's see, that's going to follow this path over here. Oh, I'm going to do that in red. So this path right here. But follow the Z. There it is. So there's our other 25 right up there. And I think I've got them all. So now that we have all the angles, and like I said, that was a little bit more work, we can write them all in. So we've got angle DEC. DEC is 63. We've got CDE. So CDE is this one, this whole thing here. We've got to add these two together, and that's 46. Angle ECD. ECD is this angle up here. It's 71. And angle DFE. DFE is all the way here. That's the 25. Okay, that's an introduction. The next part of this is going to involve some algebra.